Good morning, everybody. So I want to talk about evolutionary architecture and DevOps. So a history lesson. For a long time, particularly after the dot-com bust, many organizations focused their IT departments on cost control. They saw technology as a cost center, and they wanted things to be as inexpensive as possible, as you would with anything that is like a utility. And how do you get stability? You standardize, you stabilize, you lock things down, and you try to change things as little as possible, and you try to have as much lead time as possible and as much stability as possible. And you're focused on standardization, not using the right tool, but using the tool that you already have because you don't want things to be complex. And that's how things were for a long time. And then, all of a sudden, HBR started saying technology is the core of the business. Mark Andreessen said software is eating the world, and all of a sudden these organizations woke up and said, oh my goodness, I have to be able to respond quickly. And now you have this technology organization that has been optimized for cost control. They have gates everywhere. Everything is locked down, everything is stable, and the business comes and says, come on, IT, it's time to move. And unfortunately, optimizing for revenue generation and value creation and time to market is a very different business than optimizing for cost control and stability. And so we've had to completely rethink how we organize IT, how we develop software, and how we look at risk. And that's a lot of what I want to talk about today. So there's this feeling, this is, I'm told, the correct way to have this quote. I've got a feeling we're not in Kansas anymore. This is not the same world that we lived in a few years ago. You cannot run an IT department in the way we ran one before. What constitutes success is no longer the same as what it was before. We have to look at these things differently. And one of the ways we're doing that is through something called evolutionary architecture. And I want to describe a little bit about what evolutionary architecture is, but spend more time on how that impacts operations, what that means when we look at how we develop systems and then how we run those systems and what has to change as a result of that. So along with Neil Ford and Pat Qua, I'm working on a book on evolutionary architecture. And one of the first things, obviously, is define it. Now, this definition dodges a few things, because I very often get asked, what is architecture? And I'm going to kind of dodge that question here, too, but think of it as all of those structural things. One of Martin's definitions, which I think is quite useful, Martin Fowler, is the definition, architecture is anything that's hard to change, or architecture is what a business is most concerned about. And that's actually not too bad of a definition. Evolutionary architecture, though, is how do we approach architecture in such a way that we can make the kinds of changes, not only the kinds of changes that we can anticipate, but the kind of changes that we can't necessarily anticipate. So evolutionary architecture supports incremental and guided change across multiple architectural dimensions. And I'm going to focus in on a few of these words. Incremental, of course, that means we're not trying to do things big bang. We're trying to cut things up as much as possible so that we can limit the scope of a change. It makes it easier to debug when things go horribly wrong, as they tend to do every once in a while. But we want to be able to gradually and continually make changes, even in our architecture. Agile software development has been doing this for a long time for code. But this is not something that people who have the title architect are often very comfortable with. This is often not something that people in operations are very comfortable with. What do you mean you're changing this again? We just deployed last month. You just changed message queues 6 months ago. Why are you changing your system software? Why are you changing all of these things on me? We want to be able to do that. And guided is a very important word here. When Neil Ford actually first started talking about this, I sat in one of his talks, and he was talking about emergent architecture. And I got rather testy with him, because emergent kind of implies, oh, well, it just sort of goes where it needs to go. Evolutionary architecture is different. What we are doing when we say this is guided is we are saying that we have, in advance, decided what characteristics of our architecture are important, are most important. What are our specific objectives? We have what's called a fitness function. And like any function, it has to give you an answer. So I don't want somebody coming to me and saying the code needs to be maintainable. What does that mean? How do I test that? It doesn't have to be an automated test, but you have to be able to objectively assess whether the answer to does this pass or not is yes or no. Not maybe, not sort of. To me, one of the magical things about how we're looking at Agile now is that you have an unambiguous definition of done. There's none of this, oh, I'm 87.5% done for whatever that happens to mean. We need to apply that same kind of criteria to architecture. We need to decide in advance what are the tests. As I said, they don't necessarily have to be automated. Does our architecture have to pass? Does our system have to pass in order to achieve the objectives that we have for it? And we look at all of the different abilities, whether that be scalability, whether it be time to recovery, whether it be maintainability, all of those different things, we prioritize them for a system. I worked on a system once. It was a trading system. And in most people's mind, when they hear trading system, they hear high volume, low latency, lots of throughput, got to pump it through. This organization cared nothing about that. In their wildest dreams, they figured they might do 200 to 250 trades a day in a few years. They didn't care about throughput. What they cared about is knowing at any instant where those messages were and making sure that the message got there very quickly, because every trade was worth billions, if not tens of billions of dollars. So they didn't care that much about performance. They didn't care that much about many of the things that in other systems you care about. What they cared about was knowing exactly where any message was at any given point in time, because that represented billions of dollars. And losing one of those or delaying it for a day cost them enormously. And so that was something that we prioritized. Sure, we did performance testing. We wanted to know how it performed, but we were much more interested and much more scrupulous in our testing of the communication amongst the various systems. And so, in advance, you decide what is important to my architecture, and then you can proceed accordingly. And that's what guided means. That's why we call this evolutionary architecture instead of emergent architecture, but because we actually have an objective function. We have something that says this is what constitutes good, and we can hold up all of our decision making against that fitness function and see which one matches the best. Because obviously in any system we have to make trade-offs, and this fitness function is going to allow us to understand how we might make that trade-off. And then across multiple dimensions. We're not just talking about software architecture or technical architecture. We're talking about data architecture as well, network topology, application architecture, integration architecture. And in many of these cases, you have to trade off achieving or maximizing against one dimension to achieve an acceptable result on another dimension. Performance, for example, versus security. I might want to run an actually quite compute-intensive encryption algorithm, but that's going to affect my performance. And what might I do to trade those things off? Maybe I want to have blindingly fast reports, and that might dictate something about how I structure or architect my data. So when we talk about this fitness function, we can think about fitness functions that are specific to a particular dimension, as well as one that helps us start to trade these things off. And these trade-offs help us understand for our architecture what is most important. If you're dealing with personally identifiable information, data security is going to be something that's very important to you. So that has to be there in your fitness function. So this is our working definition for the moment of what evolutionary architecture is. And what has that given us? So why is this good? Why do we even care about this? Well, the first reason is it gives us the ability to respond quickly to opportunities. One of the real problems that we had back when IT was considered just a cost center is that getting any change out was hard and took a long time, and that meant counter to everything that we understand about software risk. You piled more and more things in because you had to amortize the cost of that testing cycle, the risk that you were running and doing any kind of deployment at all. And so you were not able to respond to opportunities. The reality is today we don't have a choice. Business model lifetimes even are shrinking, let alone changing expectations. If you don't have social capabilities, if you don't have somebody who's looking out at the latest innovation that anyone comes up with, even in the consumer space, in terms of how they want to interact with your systems, you're going to fall behind. There was an insurance company that we worked with at one point that they had differentiated themselves for decades on the precision of their underwriting algorithm. And all of a sudden, when people started quoting online, they realized that what had been their crown jewel was now their anchor, because that algorithm took 87 parameters. No one was going to sit in front of a screen just to get a quote for insurance and fill in 87 fields. They just weren't going to do it. And so they had to completely rethink their business model, tear out all of those systems that used to be considered stable and the core of their business, because all of a sudden, the expectations that people had were completely different. And there's nothing that we can do to change that. There isn't anything about an organization that causes this disruption to come from somewhere else. Next is the ability to respond to threats. Hackers, all of the bug fixes that we have to come in, as well as business threats. How do we actually make sure that we've got all of these things patched properly? We can't afford snowflake servers anymore. Those lovingly crafted servers that have things just tuned particularly right for that, and then another server over here that looks completely different. We can't afford that anymore because it takes too long to roll things out. It takes too long to figure out what went wrong. Trying to debug something when it works on one machine in production and not another machine production, and trying to figure out, okay, with all of these differences between the two machines, what's the core of the problem? How is that going to help me figure out what's wrong? So we have to be able to respond quickly to threats as well. And finally, part of what evolutionary architecture gives us is the ability to experiment. Rather than having to make a big bet, we can listen to all the different crazy ideas that people across the organization think about, because you can roll things out safely. One of the things that I distinctly remember in putting things into production and trying to monitor them as they go into production is how thrilled you are when you get to the end and nothing has gone horribly wrong. And you celebrate not the fact that you've rolled out all of these wonderful features, but that you didn't have to explain to the CEO why things went so wrong. That's the thing that you don't want to celebrate. You want that to be a given. You want deployments to be boring. Because you can't experiment, you can't roll things out more quickly if every deployment is a risk. Okay, so that's why this is good. But what does that mean? What are the implications of this? The first is that we're very likely to be changing our technology stack much more frequently. And that is going to complicate things for the development, but it's certainly going to complicate things for operations as well. When you've got an operations organization that understands how to work with a particular database and a particular set of monitoring tools, and all of a sudden These crazy developers are coming in and say, we need to use MongoDB. And they've never worked with that database before. They don't have the tools, we don't have the processes. We're accepting with evolutionary architecture that we're going to be making fundamental changes, not just to code, but to the technology stack. The stack is going to be changing more regularly, and what that requires then is much more conversation on the trade-off between, okay, we're going to gain this in terms of time to market by using this tool, and it's going to cost us this in terms of training or additional monitoring tools or additional personnel to keep this thing up and running. We've got to have those kinds of conversations. For a long time, it was either the development team had all the power or operations had all the power. Neither one of those things can happen now. We have to have time to market, but we can't be throwing these things over the wall to an ops organization that doesn't have a say in what it takes to actually make these systems work. So, this is one additional burden on operations that comes from evolutionary architecture. And it's not just that it's changing, but it's going to be more complicated. And unfortunately, that's been the reality for a while. Even if you have it locked down to, I've got one database, I have one approved database and one approved operating system and one approved this and one approved that, you still have a whole lot more moving parts in any architecture than we did even 10 years ago. The number of frameworks, the number of libraries, the number of different kinds of system software. Is this thing running in a container or not? Is this thing running in the cloud or not? All of those different technology choices, already we had a more complicated stack, and now we're empowering development organizations to introduce new things into that technology stack if it makes sense for time to market. So the technology stack is much more complicated. And then more frequent releases. We can't any longer celebrate the fact that, hey, we're now releasing once a quarter. It used to be that was worthy of celebration. You were lucky if you got one out a year, so if you got one a quarter, you're really rocking now. Even that is not sufficient. But every deployment has a cost. Every deployment comes with risk. There's no way around it. Every deployment means you've got to look at data. You've got to make sure that the data doesn't get lost. You've got to make sure that you've managed your uptime. Regardless of all of the things that you put into place to try to make those things as safe as possible, this still introduces risk. One of the prime examples of an approach to software that wouldn't have made sense before DevOps, before continuous delivery, is microservices. And when I talk about microservices, one of the statements that I make is that it is actually irresponsible to use a microservices architecture if you don't have a mature DevOps culture and if you don't have continuous delivery. It is simply too risky. It is too much of a burden on the operations department, and if operations is not involved in the discussions around the microservices architecture, it simply does not make sense. And that means for some organizations, it's going to be a while before they can get to a microservices architecture, regardless of the benefits that it might give them. Because without those things in place, without the proper communication between development and operations, without that level of mutual respect between development and operations, and without the underlying infrastructure, microservices simply puts too much of weight on an operations department, which unfortunately many of them are still recovering from this notion that they were a cost center and therefore had to be squeezed, and therefore all of the capabilities were commodity and let's outsource it all to India. I think part of the reason you're seeing the backlash in a lot of the outsourcing is people are recognizing we can't do that anymore. In fact, these systems are our primary assets, and we have to get control back of them. So that's the role microservices plays. And I'm going to repeat this. It is irresponsible and unprofessional, I believe, to use this kind of architectural style until you get DevOps and continuous delivery in order. So why is why is continuous delivery first such a mitigating factor? When we look at anything around evolutionary architecture, as I said, we're looking at changing technology stacks. We're looking at releasing more quickly. We are looking at deploying more quickly. And continuous delivery, to me, is not necessarily all about just being able to have a developer check in a piece of code and have it magically appear in production. To me, it's all about making deployment repeatable. I've been the person at 3 o'clock in the morning on a Sunday trying to deploy a system, and I don't care how good the run book is. We're human beings. We're going to make a mistake. Maybe not every time we deploy, but we're going to make a mistake. I am not at my best at 3 o'clock in the morning, and I'm one of those dreaded morning people. It just doesn't work that way. And so getting the discipline around automating your deployment, around standardizing your environments so you don't have to wonder, okay, do we have the magic switch here that's going to make this piece of code work? You want to have those environments scripted. You want to have the deployment scripted. You want to have all those things in place so that deployments are boring. So we can also, with this continuous delivery mindset, when we do bring in this newfangled thing called MongoDB, you've got that same process for deployment throughout your pipeline as you promote from a test environment into a pre-prod. And so you're testing, what does it take to install and deploy this new piece of software that we've never looked at before. Continuous delivery allows you to do that safely, to introduce new technology in a way that is much safer than it was in the past. Evolutionary database design. This is another critical part of evolutionary architecture. And when you look at the progression of how things like Agile and such have been adopted over the years, there have been many disciplines that have been the holdouts. And DBAs have been one of them. Well, I can't construct a database without knowing all of the requirements, and there's a good reason for that. Data migration. Once you're in production, any change you make to the database requires a migration. And data migration is hard. Conceptually, it's easy. You look at it, I've got data over here in this format and I need to move it over here into that format. What possibly could go wrong? But data migration is hard. You all giggled, you know, because there's that magic field that for 6 months back in 2004 was used for something completely different because we couldn't get the database updated properly. And so you've got this slew of records that have these different magic fields running around all over the place. Personally, what I think is one of the least appreciated books, particularly in terms of its potential impact, is the book by Scott Ambler and Pramod Saldalgi called Refactoring Databases. And what they do in this book is describe to you how you can really do evolutionary database design and not have it fall over in a heap when you're doing your data migration. And the basic approach is simple. Just like refactoring code, where you're making very small changes, you take a large database change and decompose it into a series of small changes. The book itself is focused on relational databases, but the same technique applies even if you're using a NoSQL database. And each one of those small refactorings, small changes to the database, comes with the data migration required to just make that change. And so just like making small code changes make it easier to figure out what goes wrong in the code, making small database changes means that when you run that test migration, you know exactly what part of the database migration is making things go horribly wrong. And so it simplifies this conceptually trivial process of data migration and allows you then to make much more radical changes to a production database than you could really conceive of previously, simply because data migrations are hard. And so this is another one of those enabling technologies or techniques or approaches that allows evolutionary architecture to take place. And it requires, though, much more collaboration between development teams and the DBAs, who very often still sit in the operations department. So of course, it's still not a panacea. Data migrations are still going to be hard. We're still going to have to figure out what happened with all of those magic fields. Eventually, hopefully, all of that data will die off. And with an approach like this, we'll never have to do those silly games that we used to have to play. Well, no, you can't add a table now, so figure out a way to slam that data into the fields that you already have. If it's easy enough to change databases, we won't do that to ourselves anymore. If it's safer to roll things out, we won't let release after release after release stack up before we actually deploy it into production and have all of that old software running. We won't do that to ourselves anymore. But there's still risks. We're still all human beings. Some of these experiments are going to fail. We're still going to miss something in our testing. And in fact, given the focus on time to market, we're less likely to do the level of comprehensive testing that often accompanied a release in the past. So we might have more things going wrong. So it's certainly not a panacea. There is no magic bullet, unfortunately. But one of the things that is becoming more and more prevalent, and I think this is in part because of the DevOps culture, is operational concerns are being treated as first-class citizens. I can remember sitting in many iteration planning meetings, and no one was representing operations and trying to get things like proper logging or figuring out how to do monitoring prioritized in the story process. And if you were in one of those organizations where the development team was king, operations didn't even have a chance to say no. That can't happen anymore. With the central role that technology and systems plays in almost every business, if those systems aren't running properly, that business is not operating properly. And that recognition is empowering many organizations and many operations groups to start to stand up and say, if you want me to do this, I need this kind of monitoring, I need this kind of logging, I need this kind of redundancy, I need this kind of staffing. And those things are starting to be taken seriously in a way they weren't. I remember one project I worked on. They'd had some message queuing software, but it was never really used very much in production, maybe on the order of a couple of hundred messages a day. But because that was the message queuing software that the organization had, when we put in something that was going to be running thousands and tens of thousands of transactions an hour through that message queue, that was the one we were going to use. And the operations manager came to me and said, we don't even have anything that allows us to monitor those queues, let alone manage them properly, and you're going to be beating these things to death. And they'd been trying literally for years to get a PO signed to buy the kinds of tools they needed to manage that messaging software. And in that particular organization and that particular time, the development group is the one that had the power. And so even as a consultant, I was able to go in and say, look, when we put this thing in production, the operations group needs this, and they signed off the PO just like that. Those kinds of things shouldn't have to happen. And we need to make sure that operations concerns are just as important as the new functionality. Of course, there's got to be a trade-off. I find it amusing when some people say, well, the business always gets what it wants. And it's like, well, yeah, maybe as a monolith, but break it down. What about audit versus marketing versus, customer service? The kinds of fights that I've seen around business functionality happen all of the time. What we need to do is make sure that we've got representation from all of the stakeholders, and operations is a stakeholder just as much as compliance, just as much as customer service, just as much as every other part of the business is. And we need to make those concerns first-class citizens. And one of the ways we can do this is through that fitness function. If time to recover is a critical success factor for a particular system, that puts an added weight on all of the stories and all of the decision-making around anything that has to do with systems recovery. And so as we put together this architectural fitness function, we're looking at all of the abilities. We're looking at monitoring, we're looking at logging, we're looking at all of the different aspects of a system, because that's what it takes to have a good architecture. We have to consider all of the different dimensions of architecture in order to define that fitness function. And that is going to vary across systems, even within an organization, because some systems are more time critical as others, they have different performance, they have different loads on them, they have different customers. So we have to think about, as we approach any individual system, what that fitness function is, and operational concerns need to come into that. So I actually see this triumvirate of DevOps and continuous delivery and evolutionary architecture working together. Evolutionary architecture, just like microservices though, is still nothing you want to try unless you've got a good DevOps culture, unless you have a solid foundation of continuous delivery. Martin Fowler has a blog post, you have to be this tall to do microservices. You have to be at least that tall to do evolutionary architecture. Because until we know that we have the ability to roll these systems out properly and safely, we can't just go in and re-architect the system just because it seems like a good idea at the time. So we need these three things to work together. The DevOps culture is critical. Having the right kind of communication, the mutual respect, the understanding of what it is that keeps each group up at night. The number of developers that I talk to that don't actually understand what it takes to keep a system running, or even more so, what it takes to get a system back up and running after it's failed. They have no concept of that. So they need to be educated. We need to be educated about that. We need to have that right kind of communication going. We need to have the level of automation and the level of deployment rigor that comes with continuous delivery. And that will allow us to use an evolutionary architecture that allows our organizations to address the changes, address the threats, and take advantage of all of the opportunities that are out there for those businesses to survive. Because business model lifetimes, and in fact organizational lifetimes, are shortening. And will just make it worse if those systems cannot respond properly. And that means putting all of the IT organization front and center at the core of a business, because that's what it is. Software is eating the world, and technology is at the core of the business. And evolutionary architecture is what is going to allow us to take advantage of that. Thank you very much. So I think we've got time for a few questions.
Yes.